Well, here if you see, so we have a epicenter. So I told you epicenter is the point on the Earth's surface. It is just above the hypocenter. It is basically perpendicular to the hypocenter, or you can say okay, directly above the hypo, and it is just kind of a perpendicular set of angle. What we shortest distance served from the crust to the surface. Okay, when we actually take a place of shortest distance, so that will be termed as what epicenter. And yes, this is the location which is preferred, the location which is always preferred for the earthquake. These earthquake effects are usually strong when the earthquake is there. So this earthquake is strong near to the epicenter, and as your distance is increasing from the epicenter, impact will become less. Okay, so the strongest be there near the epicenter, and as you are far away from epicenter, the impact are likely to. Here if you see, now you'll have a more clarity regarding the compressional forces, tensional forces, or shear stress or forces. First of all, just pay attention. Pay attention. Suppose we have a plate. What? First thing is, I hope you can, when this entire plate will going to move, this entire plate will going to move along the plate margin. We will have what? Earthquake. Why? Because there will be a vibration. They will be shaking. Why they will be shaking? Because two plates will collide with each, and as a result of that, what happens? Margin, and as the distance is increasing from the margin, yes, less energy as the distance. Certainly. The second thing is what? That we may have a faults. What are faults? Faults are like sharp rupture. Faults are like sharp breakdown. Sharp faults are like sharp discontinuity. This entire plate. See this way. Suppose we have a plate like this. A plate, but sometimes we may have some sort of rupture in the plate. So you can say that this could be what? This could be rock block and rock one. This you can this you can this you can this you can five. So whenever this plate will going to move, obviously it will be a click on this. I hope you remember, when this plate will going to move, apart from these margin, along these fault there will be a proper, let's say, the seismic energy which is, and these are being called as what? Faults. Are being called as what? Just take an example in this. Just take a plate and put some peanuts, or if you are rich, you can put almonds. So if you put almonds or peanuts on a particular plate, and if you move that plate in a particular direction, let's say in this way, so if you move that plate in this way, so those peanuts or those almonds for rich kids, if it is there, so the plate is actually moving in a definite direction. Okay, plate is moving in a definite direction, but you will see that the almonds or the peanuts, those who are actually put on that particular plate, they will have a random direction. So you can consider those peanuts or those almonds as a rock blocks which are there on that particular plate. That plate itself comprise of those rock blocks. So fractures are actually the discontinuity which you can see from the above. However, that is not from the top part to the plate, top part of the plate to the bottom part of the plate. If it is like this, from the top to bottom, then it will be a separate plate. And why we are considering this as a fault? That will be a separate plate. So suppose this plate is having 100-kilometer thickness. Thickness is 100 kilometer. So what will be the depth of fault? For example, 2 kilometer, 5 kilometer, 10 kilometer, max to max. Okay. 15 kilometer, to some extent, let's say 50 kilometer. Up to that depth, we can have a fault. This is not a that idea. Okay, I'm just giving you an example. Faults are what? The sharp rupture, sharp discontinuity in the earth crust, especially in the plate, you can. Okay, so when we have these faults, when we have these, and if we have these set of, let's consider these two, block 1 and block 1 and, so we have a block 1 and block, have block 1 and suppose these two set of blocks are under the influence of if have a like a mental convection current in this, so because of this, the rocks which are will also, so when there is a compressional forces on this particular block, when we have a compression forces on this particular block, that will lead to formation of what? If we have a tensional forces, means if there is a divergence plate boundary movement, that case what will happen? The two blocks will have a tendency to move away from each other. It's because there is a divergence mental current at the bottom. That divergence mental currents at the bottom, they are actually exerting the conveyor belt effect in the solid part of crust that lead to the movement in the rocks. Further, if there is a stress in the rocks because of the mental convectional current, rocks will going to break, a fracture will be there, fault will be there, earthquake will be there. Okay, so we have a tensional forces, and yes, similar to that transform plate boundary movement is there, so we will have what? Shear stress. Can compare in that same way. So whenever we have a convergence, we have a compressional stress, we'll have a formation of fault. If there is a divergence, we will have a tensional stress, we will have a what? Faults, earthquake. And if there is a transform, if there is a conservative, or if there is a almost parallel movement of two respective plates or two blocks specifically, so if there is a blocks, we will have what? Here, earthquake will be. So we are talking about two aspects. First of all, there is a plate. Okay? So there is an entire plate. And regarding that plate tectonics, I hope you have a clarity. Second part is what? We are looking at the minute part of the plate, which is from the top part, which is from the top surface part, and that is what? The fault. When we have so many fractures in terms of rocks. Okay, so that peanut and that plate example I gave, plate is like this plate and the peanuts are like rock blocks, and when the plate will move, along with the plate movement, we will have an earthquake. At the same time, those blocks will also going to move, so we'll also have an earthquake on the margin of those blocks as well. And those margin of those blocks or margin on those peanuts or almonds, they are being known as what kind of fault. So here we have what? If mental convectional current are operating in this way, so the blocks, rock blocks which are here, they will also have a tendency to move towards each other, compressional forces. If the mental convectional current is diverging, so the blocks which are there, they will also have a tendency to move away from each other. We'll have what? Tensional stress or tensional forces, and we'll have a shear stress. Whenever we have a parallel kind of set of movement, when we have a parallel set of movement, as a result of parallel set of movement, what will happen? The blocks which are here in this particular crust, let's say, so they will have a tendency to move like this. Why? Because the mental convectional currents are operating in this way. One is moving towards the camera, second is moving towards me, for example. So in this way, there is no divergence, there is no convergence, and the same aspect is reflected in the crustal parts. That block will going to move in this direction, and this block will go move in this. Whenever we have a shaking, that will have a, yeah. So stress on rock is one of the major reason because of which we have earthquake, apart from plate margin. Even on the plate margin, we have a stress on rock. So when continental plate is there, or suppose oceanic plate is there, So what will happen? The oceanic plate will going to subduct beneath the continental one. When the continental plate is about to collide with the oceanic plate, what will happen at the margin? At the margin, there will be a stress which will be developed on the rocks, and because of that stress, what will happen? There will be an earthquake. There will be a folding of crust. Okay. So stress is actually primarily generated by the convectional current. Why these two oceanic and continental plates are moving towards each other? It is because of the mental operating currents. Okay. And these current drags tectonic plates, applying forces on these rocks. And we have these two or these three set of forces about which just got a clarity. So compressional means what? Plates push against each other when we have a convergence. Tensional stress when the plates move towards each other. So just take an example in this way. Again, try to understand. Continental one. Oceanic one. Mental convectional currents are operating in this way. So that led to the building of stress in the rocks in this way. Similar conveyor effect will be there. They'll try to drag these two plates. They'll try to move these plates towards each other. They'll try to move these plates towards each other because of the mental convectional current. And similarly, in these crustal parts, we will have the stress which is about to build. And when this stress is beyond the strength of rocks, energy will be released. And that energy we are terming as seismic energy or earthquake. All right. When we have a divergence or when we have a tensional forces or stress, suppose we have a one plate, we have a fault this way, suppose we have another plate and we have a fault, let's say in this way. So mental convectional current are operating in this way. Because of this, what will happen? There will be a conveyor effect. There will be a stress on rocks which is going to build in this specific direction with respect to specific plates. Ultimately, what will happen? There will be a more and more stress which will exert. If the mental convectional current are further strong, this will going to further strong. The stress will going to further strong. And when the rock's strength is less than the stress, or let's say when the stress is bypassing the rock's strength, there will be earthquake. There will be seismic energy will going to. All right. So we have these two set of tensional forces, compressional forces.